Question 1, Part D. The graphs of the line x minus 2y plus 3 equals 0 and the curve y equals x cubed plus 1 intersect at 1, 2. Find the exact value in radians of the acute angle between the line and the tangent to the curve at the point of intersection. We can answer this question using vector techniques, but before we do that, we need to find the gradient of the line and the gradient of the tangent to the curve y equals x cubed plus 1 at the point where x equals 1. So let's consider the line x minus 2y plus 3 equals 0. I'm going to rearrange it into gradient intercept form, that is y equals mx plus c. And we do that by separating the 2y from the x plus 3. So 2y is equal to x plus 3. Dividing both sides of the equation by 2, we get y is equal to half x plus 3 over 2. Hence the gradient of the line is half, or 1 over 2. Now to get the gradient of the tangent to the curve y equals x cubed plus 1, we need to differentiate x cubed plus 1 with respect to x. We get f dash of x is equal to 3x squared. The gradient of the tangent at the point where x equals 1 is given by f dash of 1. So we substitute x equals 1 for x here. We get 3 times 1 squared, which equals 3. Next, define two vectors, so vector u and vector v, in the direction of the line and the tangent respectively. So I'm going to let vector u be 2, 1. So that's the x component and the y component. So that's going to be 1 over 2 if we think of it as rise over run. And that's in the direction of the line y equals half x plus 3 over 2. Notice that the y-intercept doesn't matter. It's only the gradient that's of importance. And vector v is defined as 1, 3. So x is equal to 1, y is equal to 3. So that's rise over run there, which is in the direction of the tangent. So if you recall, the tangent has a gradient of 3. Now we can use the dot product formula and solve the dot product formula for theta. So vector u dot vector v is equal to the magnitude of vector u multiplied by the magnitude of vector v multiplied by cos theta, where theta is the angle between the two vectors. Now u dot v is equal to 2 times 1 plus 1 times 3. So that's the product of the x components, 2 times 1, plus the product of the y components, so that's 1 times 3. And the magnitude of vector u is the square root of 5, if we use Pythagoras theorem. The magnitude of vector v is the square root of 10, so that's 3 squared plus 1 squared is 10, take the square root of that, and that's how we get the square root of 10, multiplied by cos theta. So on the left-hand side, 2 times 1 plus 1 times 3 equals 5. And on the right-hand side, root 5 times root 10 is root 50. And that can be expressed as 5 root 2 in simplest form. So we get 5 is equal to 5 root 2 times cos theta. Dividing both sides of that equation by 5, we get 1 equals root 2 times cos theta. Then making cos theta the subject, we get cos theta is equal to 1 over root 2. And that's a familiar ratio there. If we take inverse cos of both sides, we get theta is equal to 45 degrees, which is pi over 4 in radians.